Hello everyone, we're going to be doing Unit 5, Lesson 15 today, solving equations with rational numbers. So if you need to pause this video and get that out, if you haven't already, do so. Otherwise, let's rock. First off, it says I'm going to solve equations that include rational numbers and have rational solutions, just meaning we're going to solve some stuff that involve positives and negatives. So first off, this warm-up is very important because it's pretty much what this lesson is going to involve the entire time. So let's take a look at it. It says the variables a through h. And I should say, guys, I plan on you watching this video, follow along, work in your notebook, and pause the video whenever you need to. If I'm going too fast, just hit pause, hit rewind, and go from there. So here we go. The variables a through h all represent different numbers. Mentally find numbers that make each equation true. We don't have to do this mentally per se, but anyway, we want to find out what a is. So essentially it's saying do 3/5 times 5/3. So that's 3 times 5 over 5 times 3, which is 15 over 15, and wait a second, that's just 1. So guess what? A equals 1. 1 equals A equals 1, same difference. Let's look at this. A equals 1. Oh, they all represent different numbers. So C and D cannot also equal 1. Maybe that's what they're saying here. Let's look at B. 7 times what is 1? 7 times what is 1? Well, 7 times 1 is 1, or 7, so B can't be 1. So my guess is we need to think 7 times what is 1? If I wrote the equation 2 times B equals 10 instead of 7 times 1, I think to myself, 2 times 5 is 10. How do I get the number 5 using 10? How do I get the number 5 using 10 and 2? Well, that means I take the answer and I divide it by the problem. 10 divided by 2 is 5. It's going to be the same problem. We can ignore this. Same way to solve the solution for this one. I just took the 10 and divided it by the 2 to get B. That means I'm going to take this 1 and divide it by the 7 to get B. And guess what 1 divided by 7 is? It's 1/7. And that makes sense because 7 times 1/7 is 7 over 7, which is 1. So we found what B equals. B equals 1/7. Now let's go over here. C times D equals 1. This one's tricky. But what times what is 1? Well, we could say 1 times 1 is 1, but unfortunately it's got to be different numbers. C, we already have A is 1, so we can't choose 1 anymore. So let's say we choose 2. Oh, this is going to be a long day if this is going to happen. We went all the way back to lesson 8. I wish I could pause this and not waste your time, but these iPads, the recording function I use is just, it's an all or nothing thing. Where are we? Sorry about this. Getting there, here we go. Let's try not to zoom in so much. So C times D, let's just say C is 2. Well, 2 times what is 1? Well, let's use the same thing we just did on the last problem. Means I take this 1, I divide it by, take the answer divided by the problems. 1 over 2 means C could equal 2, like we just said, and that means D equals a half. 2 times a half is 1. In other words, what's half of 2? It's 1. So we've got that. Let's just jump straight down here to F. 11 plus what is 0? 11 plus 0 is not 0. 11 plus 1 is 12. So we got to go in the negatives, and maybe we're realizing, well, F must have to be negative 11. That's called an additive inverse. And believe it or not, these two are called multiplicative inverses. Multiplicative inverses. So I got F equals negative 11. Let's go over here. A negative 6 plus 6. Well, E equals 0. Got that one done. Guess what? Those are also called additive inverses, just like this one right here. 11 and negative 11 are additive inverses. And we get to make up any number we want for G and H, as long as it's not one of these numbers we chose, and as long as it's not 1, 1/7, 2, a half, 0, or negative 11. So how about what we just learned? And you actually, I'll let you make up your own. Go ahead and write down. But they have to add together. So one's going to be positive, one's going to be negative. They both can't be 0 because they have to be different numbers. So I'll leave that up to you to finish that one. But long story short, these are called multiplicative inverses. If you multiply them together, they they multiply. The product is 1. These two, 1/7, 1/7, and 7, those are multiplicative inverses. They multiply together to get 1. 2 and a half are multiplicative inverses. You multiply those together, you get 1. And then these last 3, this one, and this one, are called additive inverses. They add together to get 0. Additive inverses, we try to get 0. Multiplicative inverses, we try to get 1. So we'll get back to that in just a second, because that's our last activity today. But this one says, let's match each equation to its solution. Be prepared to explain your reasoning. So let's look at A. It says 1/2 x equals a negative 5. Half of something is negative 5. We could ignore the negatives if we want and come back to them for multiplication problems. Doesn't always necessarily work for addition problems, but we kind of can. But it's saying half of what is 5? Half of what is 5? Well, if I wanted to really solve this, if half of something is 5, if I doubled that 5, if I took that 5 and doubled it, that would get me 10, because I know half of 10 is 5. If half of 10 is 5, then half of a negative 10 is a negative 5. And notice, if we said 10 is our answer, it's not one of the solutions on the right, but I do see a negative 10. So we can go ahead and connect those two. So let's look at the next one. It's saying a negative 2 times something equals a negative 9. Negative 2. If I double something, I get 9. Again, I'm ignoring the negatives. I do know a negative times a positive will give me a negative. So whatever x is, whatever x equals, it's going to be positive. So I can eliminate number 1 is not the answer, number 2 is not the answer, number 6 is not the answer. So it's got to be 5 or 4. And we think to ourselves, well, 2 times what is 9? If I double something, I get 9. So if I take 9 and I cut it in half, guess what? I'll get 4.5. Yeah, so that must mean I got that one. This next one is tricky. This next one is saying half of something is a fourth. Half of something is a fourth. Half of something is a fourth. Half of what is a fourth? Half of 1? Half of 1 is 1. Well, let's just go to the positive negatives and let's see if we can eliminate some problems. I do know that a negative times a negative equals a positive, so my answer must be negative. Unfortunately, that leaves 1, 2, and 3. And now I'm thinking to myself, is half of 4.5? I'm looking at the number 1 right now. It's half of 4.5 a fourth? No, half of 4.5 would be 2 something. Is half of a fourth? That sounds right. And the other negative one is number 6 is half of 3.5. No, half of 3 is like 1.5. So it's got to be number 2, but we got to be able to explain our reasoning other than just saying it's the only one that fit. If I want to find half of something, well, that means I need to double the other thing in order to know what half of that would be. So if I took a fourth and doubled it, that would give me 2/4. And guess what? That's actually our answer, other than we know our answer should be negative. 2/4 is 1/2. A lot going on in that problem. I'm going to erase over here so I have some space. And let's look at letter D. -2 times something equals 7. -2 times something equals 7. -2 times something equals 7. Let's ignore the negatives. I do know that a negative times a negative will equal a positive. So I know x has to be negative, and that, well, by process of elimination, that leaves 1 and 6. So something doubled equals 7. If something doubled equals 7, then if I took 7 and cut it in half, I would know what that is, and that's going to equal 3.5, but I know my answer must be negative, so that means number 6 must belong there. And letter E, something plus a -2. That's kind of like saying something -2, because remember, subtracting is adding the opposite. So -2 would be the same as adding the opposite of 2, which is -2. And let's look. It's either 5 or 1. It's 5 or 1, so I'm going to come over here and give us some space over here. So something -2 equals a -6.5. Something plus a -2 equals a -6.5. Whether or not you recognize this, if I want to take 2 away from something to get -6.5, in other words, if I said x minus 2 equals 5, you all would say, well, what -2 equals 5? You would always say, oh, it's 7. 7. If I take 2 away from 7, I get 5. Well, how did I get that answer using these two numbers? Well, you would say, oh, I took 5 and I added a 2. We're actually going to do the same thing. I'm going to take this -6.5 and I'm going to add 2 to it. And we go to our rules. A -6.5, if I add 2 to it, they're different signs, means I subtract them and I keep the sign. 6.5 minus 2 is 4.5, and I keep the larger one sign. So my answer is negative 4.5, which belongs with number 1. And let's just, for the heck of it, a negative 2 plus what is a half for the last one? We know it's number 5. A negative 2, what can I add to it to get to positive a half? Well, if I added 2, I'd be at 0. So I need to add half more, which means that 5 goes to that one. So a lot going on in number 1, but there was a lot of additive inverses and multiplicative inverses going on there. But we'll get to that more. Activity 2 is ridiculously important, and one of the more important lessons, I could say, if we're do activity 2 and we get it and we can understand it. Probably top 10 things to understand in all of 7th grade math. So I want you guys to pause this, give it a try, read it, and then unpause it, watch the video, and see what you come up with, because that way you learn it best. If you just listen to it, it's not that bad, but it's not going to stick in your brain. Our brains learn a particular way, and just by listening and someone it does learn that way, it's just not the best way we learn. So I want you to pause it. I want you guys to try activity 2 all the way up to number 4. Don't worry about the are you ready for more, although it's a good problem. But go ahead and hit pause. Look at some of these. There's no doubt that you'll be able to do this. But I want you to try it on your own and see if you come up with something similar to what I come up with. So go ahead and pause, and then hit unpause, and follow along with me after you've tried it. All right, kudos to those of you that listen to me. But I'm not going to lie to you. Some of you aren't fooling me. Some of you didn't hit pause. So be it. The hiking club is on a trip to hike up a mountain. It's good that the hiking club is hiking. The members increased their elevation 290 feet. They increased their elevation. They went up 290 feet during their hike this morning. Now they're at an elevation of 450 feet. Explain how to find their elevation before the hike. They were at 450. They were at 2. No. We don't know where they're at. Explain how to find. We just know they went up, and now they're at 450 feet. Well, hopefully we all know, well, if they're now at 450 and we took away what they went up, we'd be where they started at, which is 100% correct, right? Which is 100% correct. Now, that's hopefully what we said for A. Maybe you just said subtract 450 from 290, whatever. Part B says, Hans says the equation E plus 290 equals 450 describes this situation. What does E represent? So Han is saying E plus 290 equals 450. What that means is well, E is not just, they could pick any random letter, but E is a good letter to choose because that stands for elevation, but not just elevation, because 290 is elevation, 450 is elevation. What do they mean? What does E stand for? E stands for their starting elevation. Now, why? Because if we took their starting elevation and they went up 290, if we added 290 to it, well, that leaves them at 450, which is why that equation represents exactly the situation that was described in the problem above. The members increased their elevation 290 feet. Now they're at 450 feet. So if we said E plus 290, notice question A is the question B is the equation. So these equations are very important to try to understand because this is what we're going to be doing for the rest of the year and pretty much all of 8th grade. So the starting elevation is E. E plus 290 equals 450. So E stands for not just elevation, the starting elevation. Now Hans says that we can rewrite the equation as E equals 450 plus a negative 290 to solve for E. In other words, if we want to say, well, then what must E be? What must their starting elevation be? Compare Hans' strategy to your strategy for finding, well, I don't know what you did, but if you remember what I did, I said, let's take 450 and subtract 290. Hans said, let's take 450 and add a negative 290. And guess what? If we follow our addition rules, if they're same signs, add, different signs, subtract. They are different signs. 450 is positive. Negative 290 is just that, negative. That means subtract. Guess what? We almost have an identical strategy. He said plus a negative. I said just minus. I just said 450 minus 290. And, well, you have to do the same thing. So, very, very, very similar strategies, just barely written differently. Adding a negative is the same as subtracting. So, there we go. Let's look at problem 2. The temperature fell 4 degrees in the last hour. So in 1 hour, it went down 4 degrees. Now it's 21 degrees. Write and solve an equation to find the temperature it was 1 hour ago. So the temperature fell. The temperature, let's call it X. Or let's just say T, but T often means time, but who cares? We could choose Q for all we care. The temperature fell 4 degrees. So the temperature was something. It fell. It went down 4 degrees. Now, it's 21 degrees. So there's actually the equation. Easier said than done. But we had a temperature. It went down 4 degrees. And when the word now often means or is means equals. So the temperature, take away 4 from the previous temperature, that gives us the current temperature, which is 21 degrees. So we think to ourselves, we can do this in our head. What minus 4 is 21? We go, oh, well, 25 minus 4. If I had 25, how do I solve that? Essentially, I'd take 21 and add 4 to it. I'm actually kind of doing the additive. What if I get rid of this negative 4, I shouldn't put parentheses around it, otherwise that means multiply. But that negative 4, oops, if that says negative 4, that means I need to add 4. If it says to take away 4, it means I need to add 4 to get our answer. And that means our answer is 25. So this is the hardest part. I think we could all look at that problem and solve it, but we've got to write equations. And believe me, these equations really help us when the problems get more difficult. Problem 3, there are 3 times as many students participating in the hiking trip this year than last year. There are 42 students on the trip this year. Explain how to find the number of students that came on the hiking trip last year. There are 3 times as many students participating in the hiking trip this year than last year. There are 42 students on the trip this year. So 42 is 3 times bigger than it was last year. 42 is way bigger than it was last year. So last year's was much smaller. So how could I make 42 smaller? Well, 3 times doesn't mean it's not 3 more. If it was 3 more, that would mean I would just subtract 3. I would take 42 and take away 3. But 3 times as many means I need to take 42. I need to take 42 and split it 3 ways so that I know what it was last year. So if I did 42 divided by 3, I'm going to go up here. How many 3s fit into 42? Well, 10 can. That'd be 30. That leaves 12 left. 3 goes into 12 4 times. So 10 and 4. That means there's 14 kids last year. If there's 14 kids last year and there's 3 times that this year, well, 14 times 3 gives us 42, which is the number this year. So there. Explain how to find the number of students. Take 42 and split it 3 ways. That'll give us last year. So just even writing that is good enough explanation. Hopefully you wrote something similar than that. My says the equation 3s equals 42 describes a situation. What does s represent? Well, 3s equals 42. I see the number 3. I see 42. What do we think s? 3 times what is 42? Hopefully we say s stands for the number of, not just the number of students, number of students last year. My S's and 5s always look the same. So 3 times the number of students last year. If we triple the number of students, number and a letter next to one another mean multiply. My says she can rewrite her equation as s equals 1/3 times 42 to solve for s. Compare my strategy to your strategy. We said let's take 42 and divide it by 3. My said let's take 1/3 and times it by 42. Well, let's do that. 1/3 times 42 means I have 1 times 42 on top. And if I want to, I can write that over 1. But fractions just as a numerator times the numerator, denominator times the denominator. And I get 42 over 3. And then wait a second, 42 over 3 exactly means just that. So taking 1/3 of something and dividing by 3, it means the exact same thing. It means divide it by 3. It means split it 3 ways. Either way, we get 14. So very similar, if not identical ways, just written ever so slightly. We wrote divide by 3. She wrote times 1/3. And if you remember, dividing by 3, if I did keep, change, flip, that's the same as multiplying by 1/3. Changing the divide and flipping the 3. 3 flipped is 1/3. Problem 4, the cost of the hiking trip this year is 2/3 of the cost of the last year's trip. This year's trip cost $32. Write and solve an equation to find the cost of last year's trip. So let's read that again. The cost of the hiking trip this year is 2/3 of last year's. So I'm going to write it kind of here. 2/3 of last year's. Does it say last year's? No, we don't know. 2/3 of, so I'll use a dot, last year's. Put a question mark, or let's use G. Last year's trip. Just for the heck, I just picked any letter. Or we could have chose C for cost. Maybe we'll do that. 2/3 of the cost of last year's trip is equal to this year's trip. The cost of the hiking trip this year is 2/3 of last year's trip. 2/3 of last year. 2/3 of last year is this year. And this year's trip is 32. Now, how are we going to solve that? Let's go back to what we did last problem. How did I solve this equation? 3s equals 42. I took the 42 and divided it by 3. Or 1/3. The multiplicative inverse of 3 was 1/3. So I took the 42 and times it by 1/3. The multiplicative inverse of 2/3 is 2/3 upside down, the reciprocal, 3/2. That might sound like gibberish, but let's do it the old-fashioned way. If I said, hey, 2 times what equals 10, if I said 2 times the cost equals 10, how did I solve it? Well, we all know it's 2 times 5. Again, how do I get the number 5? I take this number and I divide it by that number. So I'm going to do the same thing. I'm going to take this number and divide it by that number, which is 32 divided by 2/3. Or, as it ends up, I'm going to take 32 I'm going to do keep. I'm going to do change. I'm going to do flip. 32 times 3 over 2. And I'm left with 32 times 3 over 1 times 2. There's an invisible 1 there if we needed to write that. And 32 times 3 is going to be 96 if I need to get a calculator, or I write it out. But 32 times 3 is 32 plus 32 is 64 plus another. That'd be 96 on the top. Half of 96 is going to be 48. Guess what? The cost of last year's trip was $48. So the tricky part is that's technically a multiplicative inverse. Notice, in order to solve that problem, it said 2/3 times something. The way we solve that is we multiplied by the inverse of 2/3. Guess what? 43 times something is 42. How did we solve that? We times it by the inverse, 1/3. There we go. T minus 4, how did we solve that? We added the inverse of minus 4. We added 4. So we have what are called, when it's a adding and subtracting problem, we add or subtract the opposite, whatever gives us 0, the additive inverse. When it's a multiplication or division problem, in this case, multiplying problem, we multiply by the multiplicative inverse. We're going to practice some of that right now because this says there's a card sort matching inverses activity. Your teacher will give you a set of cards, match the numbers with their additive inverse, then match the numbers with their multiplicative inverse. So that means additive inverse. What's the inverse of 3 for an additive inverse? It would be a -3. What's the inverse of a -1/2? It would be a +1/2. These are all additive inverses for this one. Multiplicative inverses. Well, what would 25 times what it's saying is gives me 1. So in other words, if 25 times something gave me 5, the way I'd solve that is I'd want to multiply it by 1 over 25, which essentially is dividing by 25. That's the multiplicative inverse. If it was -1/5, the multiplicative inverse would be it flipped upside down. So I didn't have to, but these are what we call multiplicative inverses. If I multiply them by each other, I get 25 over 25. I get 1, right? -1/5 times 5 over 1, or -5 over 1, that's 5/5, or negative times a negative is positive. It would be +1. So multiplicative inverses, we're trying to multiply two numbers together to get 1, because that actually helps us solve a lot of equations. And additive inverses, we try to get 0, and that helps us solve a lot of adding and subtracting problems. So guess what? I have added a link. If you go to this link and click on it, you will be taken to a page that looks like this. And then you'll scroll down and you'll see a bunch of cards right here. Here are your additive inverse cards. And then right below are your multiplicative inverse cards. So if we were to match some of these, we won't do them all, but it's kind of like saying, hey, a -25, what do I add to that to get 0? Well, hopefully we say -25 plus 25 gives me 0. So do we see 25? Yeah, it's right there. So let's drag that and put it right there. So we got that one done. How about let's do 0.25. Well, 0.25 plus what gives me 0? Well, a -0.25. Do you see a -0.25 anywhere? Does anyone see a -0.25? Yeah, me neither. So we're going to have to look at the fractions. Are any of these fractions a -0.25? And hopefully you recognize, hey, 0.25 is like 25 cents. 25 cents is like 1/4 of a dollar. So what's 1/4? What would be -1/4? Guess what? We can match those two together. There we go. Let's do one more. What would I add to a negative 0.2. Well, I need a positive 0.2. Does anyone see a positive 0.2? Yep, there it is. These two added together give me 0. These are all additive inverses. If you want, take a few minutes and see if you can figure that out. Let's look at this 0.1. 0.1 plus a negative 0.1 will give me 0. So where is there a negative 0.1? I don't see one. So I might have to think to myself, 0.1, by the way, is 1. That 1 is in the 10th place. I actually have 1/10. So 1/10 plus a negative 1/10 will give me 0. And hopefully we recognize these two fractions go together. So if you want, try a few more. The hardest one might be, not that hard. Luckily, these are matched. 4 and negative 4 1/100ths. Negative 10 over 1 is just a negative 10. So 10 and a negative 10 go together. If you want, pause this video and see if you can match and then see. But 2 plus a negative 2 go together. 4 and a negative 4 makes 0. 3 and a negative 3 makes 0. Negative 5 and a positive 5. I don't see positive 5, but I do know that 10 over 2 make 5, so those go together. Negative 0.5, hopefully you recognize, is the same as a half, and 5/10 is a half, and those are actually 5/10 and 5/10, and so forth. I think there's 1/3. Does 1/3 have a match? Oh, there it is. All right. Now these are multiplicative inverses. The multiplicative inverses It's a long, long lesson. We're looking at numbers that multiply to give us 1, right? So if I looked at negative 25, just like that last problem, 25 times what is 1? Well, 25 times, I wish I could write on this, but 25 times, can I write down here? Can I write up here? No, I can go back a screen. But if you remember, 25 times 1 over 25, I'll go, oh yeah, all I got to do is click over here. If you remember this, that was a coincidence, I didn't realize. Those two multiplied by each other give me 1. So I'm looking at, for a number, I'm looking for 1 over 25. Whoops. And nowhere here do I see a 1 over 25. That's not a 1 over 25. None of these fractions are 1 over 25. So we have to look at these fractions a little differently and see if we can find one that is 1 over 25. 1/3 doesn't change. 1 over 4, no. 1/3, 1/10. 4 over 100 is close, but it's got to be negative because a negative times a negative is positive, and we need it to be a positive one. And if you look, this 4 over 100, actually, if I simplified it, would be 1 over 25. 1 over 25, 1/25, if I did on a calculator, 1 divided by 25, it would say it is 0.04, which is 4 100ths. That was a hard one to start off with, but the next one is 5. Well, 5 times 1 over 5 gives me 1. 5 times a fifth, that'd be 5/5. Do I see a fifth anywhere? I see a third, I see a fourth. I don't see a fifth anywhere. 1/5. Anyone see 1/5? Nope. So I don't see fractions. So I'm going to get on my calculator and do 1 divided by 5, and it tells me it's 0.2. So guess what? Those two match together. There we go. And I have not kept track of time. And my son is home now. And it says everyone's back from the library. They just went to the library to get some books to read for this week. Hi, big girl. Say hi, everyone. Say hi. Say hi.
Hi.
Say hi, Bug. We're making a recording right now. Oh my goodness, look at the boat you made.
This is the goodest one. These are some eagles. These are some windows. There's
What did you
windows.
make,
There's
Stevie?
the window. These are some stairs, and there's a bed.
You made what?
And here's the sun in the sky.
Oh my goodness, it's
And
beautiful.
this is the boat.
Okay, I'm gonna finish this recording. I'm making a recording for my students.
Dad, I guess
the
what we're
math
having
we're doing?
for lunch.
What are we having?
Noodles.
What grade is this?
7th grade.
Hi, 7th grade.
I peed my pants.
Yep, let's go.
You peed your pants? Thanks for telling me. Thanks
I'm
for
getting
telling me.
something out.
Remember, we try to get that in the potty next time, okay?
I'm putting the stick.
And there you have it, everybody. I guess we could be happy we didn't pee our pants. So let's call it a wrap. Unfortunately, I typically like to try to do some of the practice problems with you. I'll attach another video if you need help with that. Go ahead and do lesson 15 practice problems for homework. And like I said, I'll attach another video for that if you need help. But you can email me if there are questions or concerns. Other than that, if you did not like this video, please click that like and subscribe button. It really helps me out. Makes it rain some dollar bills up in here. So, peace. I'll talk to you guys later. Keep up the good work.